students, a very warm welcome to my channel Ritu Garg Maths Classes. Today we are going to understand the topic of multiplication of complex numbers. Let Z1 and Z2 be two complex numbers, and we are going to do the topic for the first time. So I am going to take the two complex numbers in general. How to add these two complex numbers Z1 and Z2. Let's see. Z1 into Z2 is equal to a plus iota b into c plus iota d. जैसे आप पॉलिनोमियल्स को ऐड करते मल्टीप्लाई करते हो, सेम वे दीज विल बी मल्टीप्लाइड वन बाय वन. a into c ac plus iota into ad plus iota into bc plus iota into iota square into bd. Now since iota is common in these two terms, let's take it common, and iota square is equal to -1. So I'm going to put down the value of iota square as -1. Now this is a pure real part which will be written in front. So it becomes AC minus BD plus iota into AD plus BC. This is a simple process of multiplication. Now let's come to their properties. The first property is the closure law. As the name suggests, I'll focus on this word closure. You have seen I had just multiplied two complex numbers and the result is again a complex number. Means हमारे पास एक सेट पड़ा है कॉम्प्लेक्स नंबर्स का, उसमें से दो कॉम्प्लेक्स नंबर्स लिए, उनको मल्टीप्लाई किया, उसी सेट में से रिजल्ट आ गया. So we can say the set of complex number is closed under multiplication. Since multiplication of two complex numbers is again a complex number, this implies the set of complex numbers is closed under multiplication. So उसका रिजल्ट लाने के लिए आपको बाहर से कोई अवेलेबिलिटी की जरूरत नहीं है, उसी सेट में से रिजल्ट्स मिलेंगे आपको मल्टीप्लिकेशन के. So this is the first property, the closure law. Second property is the commutative law. If I have two complex numbers and I multiply Z1 and Z2, and maybe possible I multiply Z2 with Z1, the result will be the same. Let's see by taking an example. I have taken an example. Z1 is equal to 2 plus 3 iota and Z2 is equal to 4 minus 5 iota. Let's see how this works out. Z1 into Z2. 2 plus 3 iota multiplied with 4 minus 5 iota. Either you can go with the whole process like I had done over here. Each and every term will be multiplied with another and then the process will be complete. Or you can directly use this formula. If I use this formula, it is AC minus BD. A into C. 2 4s are 8. Minus BD. Minus as such BD. B is 3 and you can see here, I have taken the terms from here. B is 3 and D is minus 5. 3 into minus 5 is minus 15. So minus minus is plus. And plus iota into. This is a real part. Plus iota into AD. AD. 2 into minus 5 gives you minus 10. Plus BC. Plus 3 into 4. That is 12. So I am going to get 23 plus 2 iota. Either you can do the whole process or you can just use the formula. Now, let's solve RHS of this. Z2 into Z1. Now I will be writing Z2 in front and then write down the value of Z1 and again apply the same formula. Now this is A, B, C and D. The formula will remain to be the same. AC minus BD. A into C. 4 2s are 8 minus BD. Minus 5 into 3. Minus 15. So it is minus minus plus. Plus iota into AD plus BC. A into D. 4 3s are 12 plus BC minus 5 into 2, that is minus 10. So again Let's simplify it. 8 plus 15 is 23 plus 12 plus minus 10. That is 12 minus 10. It is 2 iota. You can see 23 plus 2 iota is matched. Therefore, we can say the two complex numbers commute while taking multiplication. They can easily interchange their places. So, it does not create any problem if I multiply Z1 with Z2 or Z2 with Z1. The third law is the associative law. When we take the commutative law, we just take two numbers, and when we are going to do the associative law, we will take three numbers. Supposingly, I have given three complex numbers in the whole class and I tell the students to multiply. Many of them will be multiplying Z2 and Z3 first of all, and then they multiply that with Z1, keeping Z1 in front. Or some of the students may multiply Z1 and Z2 first of all. उनको लगेगा कि शायद ये easy है, ये पहले कर लेते हैं, and then multiply Z3. The result will be the same. You can verify by taking some example. You can take example Z1 and Z2 these same and Z3 some another number, and then solve for LHS and RHS separately. You will see the result is coming out to be the same. Let's continue with the next property, fourth property, the existence of multiplicative identity. I will again focus on the name because these properties are really easy if you understand the name well. Suppose I do have a complex number Z. I want to multiply into this number something which gives me the identical result. अब मैं Z में क्या multiply करूँ कि मेरे पास identical result आ जाए. Identical means the same result आ जाए. Obviously you will be telling just multiply it by 1. So now problem is that this is a complex number, so I should have this number as a complex number only. So which is not a big problem because anytime 1 can be written as 1 plus 0 iota. So it means I have multiplied Z with 1, a complex number with another complex number, so that the result is identical. Therefore this 1, that is 1 plus 0 iota, is the multiplicative identity of Z. So for very simple complex number, you have got a very simple multiplicative identity, that is 1. आप किसी भी complex number को 1 से multiply करोगे तो result क्या आएगा? Identical. Next is fifth, the existence of multiplicative inverse. Let's understand the name again. I do have a complex number Z. I want to multiply this complex number with some number such that it gets finished. It gets its identity back. Identity क्या थी? 1. ये identity पे पहुंचना चाहता है. अब मैं Z को किससे multiply करूं कि I should get its identity back? Obviously, everybody would tell me, ma'am, just multiply with its reciprocal because these two will cancel down and the result will be 1. So this 1 by Z, which made Z into identity, is the multiplicative inverse. This implies 1 by Z, that is Z raised to power minus 1, is the multiplicative inverse of Z. Let's take an example for understanding these two once again. Find the multiplicative identity as well as the multiplicative inverse of any number 2 plus 3 iota. Let's do the solution. Supposingly you get this question in 2 marks, so how you will be going for? First of all, label the complex number. That is a very crucial step so that you can easily denote it with the number Z. Now, multiplicative identity. is equal to, if you have done this topic well, you very easily know that multiplicative identity is 1. That is 1 plus 0 iota. Now how to justify it? हमें इन दोनों को multiply करना पड़ेगा. Let's see. 2 plus 3 iota multiplied with 1. Obviously will give me the same result. Identical result आ गया. So ये multiplicative identity बन गई. And multiplicative inverse. टॉपिक किया हुआ है, आपको याद है मल्टीप्लिकेटिव इनवर्स क्या होता है? आपके दिमाग में है कि अगर z मेरा कॉम्प्लेक्स नंबर है तो 1 by z क्या होगा? मल्टीप्लिकेटिव इनवर्स. अब z की वैल्यू डाल देते हैं. द प्रोसेस डज नॉट फिनिश ओवर हियर. यहाँ पर आपको थोड़ा सा और आगे जाना है, बिकॉज लाइक इन 9th क्लास वी हैड डन द रैशनलाइजेशन कि हम डिनोमिनेटर में अंडर रूट नहीं छोड़ते कभी, इसी तरह से उसको रैशनल कर देते हैं. इसी तरह से यहाँ डिनोमिनेटर में यू आर नॉट गोइंग टू लीव कॉम्प्लेक्स, यू आर गोइंग टू multiply and divide by the same number with the opposite sign. यहाँ 2 plus 3 iota है, तो आप इसको किससे multiply and divide करोगे? 2 minus 3 iota से. Let's see. Numerator gets multiplied with the numerator. 2 minus 3 iota divided by a plus b into a minus b. The formula stands for a square minus b square. A square minus b square. A is replaced by 2 minus b is replaced by 3 iota whole square. So it is 2 minus 3 iota divided by 2 square is 4 minus 3 iota square. पहले 3 का square कर लेते हैं. It is 9. Iota square is minus 1. 9 into minus 1 means minus 9. So this negative becomes positive. Now 4 plus 9 is 13. So we split the number as 2 by 13 minus 3 iota by 13, because these numbers are very easily transferred with their multiplicative identity, multiplicative inverse. So the properties do not end over here. The last property is for, let me tell you the last property also. The last property stands for the distributive law. Now we have done the properties of multiplication as well as addition. So we are ready to do the distributive law. Distributive law. Supposingly, I have 3 complex numbers z1, z2 and z3 and I want to solve for this. Some of the students will actually be adding z2 and z3 first of all and then they'll multiply with z1. But some will think that this z1 can be multiplied with z2 plus and then this can be multiplied with z3. This is known as, this product of z1 has distributed over the addition of complex numbers. If you want to justify it, if you want to verify it, you can take 3 complex numbers and solve the LHS and the RHS separately. You will see the result will come out to be the same. Or supposingly आप z3 product को पीछे रखना चाहते हो, even then there is no problem. It will be z1 into z3 plus z2 into z3. Sometimes while doing properties हमें ऐसा लगता है कि maths has come into a very theoretical picture, but don't worry, the questions are really simple and these properties are basically for usage in the questions.